We're going to look at the physical properties of molecular substances. And this is an extension of the work that we have done on covalent bonding. So if we think about a simple molecular substance such as methane, which has the formula CH4, we have molecules, and these molecules have very strong covalent bonds. And these bonds are, in this case, between carbon atoms and hydrogen atoms. However, between each molecule, there is a different type of interaction, a different type of force. And these are very weak intermolecular forces. So we've actually got two things happening in a molecular substance or in a covalent substance. We've got covalent bonds inside the molecule, so between the carbon atoms, but between molecules, intermolecular bonding, in between the molecules, we've got very weak intermolecular forces. And it's these intermolecular forces, these very weak intermolecular forces, that determine the melting point and the physical properties of covalent or molecular substances. So we'll often see this word covalent or simple covalent substances and molecular substances used together. And they effectively mean the same thing. So covalent substances and molecular substances are words that we're going to interchange. So in terms of the main physical property, then molecular substances have low melting and boiling points. So low melting and boiling points. And this is as a result of the weak intermolecular forces. And this means, because they're weak, little energy, not much energy, is needed to overcome these forces. So the fact that we've got these weak intermolecular forces that require little energy to overcome them, we have low melting and boiling points. As a result, molecular forces tend to be gases and liquids at room temperature. So we can also use this to explain one of the trends in melting points and boiling points that we've seen before. So if we have a look at the group 7 elements, then the first element is fluorine at the top. And fluorine is made up of fluorine molecules, F2 molecules, where we've got two fluorine atoms covalently bonded to each other, but then an extremely weak intermolecular force between them. As we go down the group, the sizes of the molecule, the atoms, and therefore the molecules increases. So chlorine, which is under fluorine in the periodic table, have larger atoms and therefore larger molecules. So the intermolecular force between them is getting a bit stronger. It's still a relatively weak force, hence the reason why chlorine is a gas at room temperature, as is fluorine, but the relative strength compared to each other is starting to increase. And then when we get to bromine underneath it, we get even larger atoms and therefore even larger molecules, and therefore our intermolecular forces become stronger still. So this really tells us that the strength of intermolecular forces depends upon the size of the molecules. So the larger the molecule, the stronger the intermolecular force, and therefore the higher the melting point. The last thing that we need to know about molecular substances is the fact that they do not conduct electricity. And the reason they do not conduct electricity is because there are no moving charges, or no charges that can move, or no charged particles that are able to move. Thank you very much.